we need to review what we did last class. Okay? Last class we said if we had f of x equals the absolute value of x, let's make this g. G of x, what's happening if I have absolute value of x plus 2? Vertical shift, what'd you say? Up 2? Does anybody agree with him? 3 people nodding. Excellent. Okay. Is that dark enough for you guys, or do I need to write with something thicker? Okay, hold on. I thought I had like a felt tip pen, but I don't know where it is right now. Okay, I'll write with this. How about this? Is that better? Okay. So what if h of x is the absolute value of x minus 1? What kind of transformation is that from the parent function? Just vertical shift down? Oh, 1. Okay. So let's make j of x equal negative absolute value of x. What kind of transformation from that is the parent? Say it louder. Uh-huh. Okay, somebody over here said reflects across the x-axis. And then I wrote reflects over the x-axis. Why did I not write across? Why did I write over? There's less letters. That's why I wrote over and not across. If you want to write across, you go right ahead. Okay? So using the same kind of thought process, I'm going to write our next 2 transformations. Do you guys remember these, by the way? These were all from Friday. We did vertical shifts and we did reflections over the x-axis. Okay? So here's our 2, well, the first 2 we're going to talk about today. If we're looking at this one that we did, the first dark one, okay, first one that you could actually see on the board, absolute value of x minus 1, where's the minus 1 compared to the original parent function? We talked about this a little bit on Friday, very, very briefly. Where is this 1 in relation to this parent function? It's not inside of it, so it would be not inside. Oh, outside. Yeah, it's outside. Okay? Where is this negative sign compared to the absolute value? The original parent function. Outside. Where is the plus 2 compared to the original parent function? Outside. What's true about every single one of these? Vertical, vertical. Is this a vertical change? If I go from here to here, is that a vertical change? Did I flip it over the x-axis? Isn't that a vertical change? So if what's happening to our original parent function is outside, what can you tell me? It's some sort of vertical change, right? Either a shift or something. A reflection in this case, okay? So where is this 4 compared to the original function? Inside. So if it's outside, it's a vertical change of some sort. Can you make a conjecture about what's going to happen if it's inside? Kind of, but we just don't use that word. What do we say instead? Yeah, it's a horizontal, right? That's what you meant, isn't it? I figured you knew what you meant, but just we're going to use the word horizontal, okay? So watch what this does. If it's x minus 4, this is a horizontal shift, right 4. A horizontal shift to the right 4. Now, tell me why you think I'm wrong. Because some of you looked back here like, because you were worried that I wrote the right word down, right? Well, what would you think that this word should be? Left, okay? But I'm telling you, I promise it's right, okay? If it's x minus 4, we're going to move right 4. I could take the calculator out and show it to you. We're not ready for that. We'll get there eventually because I do want you to see a visual of that. For right now, I just want you to know the rules, okay? The transformation rules, okay? So there's a couple different ways that I've seen this taught, and I'm actually going to show you about 3 or 4 different ways that I've seen this taught, because who knows better than you how you learn best? Nobody, right? Especially not me. I've only known some of you a week, right? So I'm going to show you a couple ways to try to help you get this in your head about why this is true. Okay? First of all, somewhere near the top of your notes, I want you to write this down. F of x equals absolute value, bx minus h plus k. That's supposed to be an absolute value. This is the general form of any sort of transformation for absolute value. Okay? It's the real mathy math form. So the first way I've seen this taught, so people remember what to do, people remember what direction, this is how I've seen it taught. If it's x minus 4, it moves to the right. God bless you. It moves to the right because I've honestly seen it taught that way. People are just like, you just have to believe me. Let's go with it. Okay? Please understand, I won't purposely lie to you about math stuff. Okay? I might accidentally say the wrong word every once in a while, but I'm not going to lie to you about math stuff. That would just make you dumber at math. That's not my goal, right? So, I'm not going to purposely make a mistake like this. But I also don't want you to just have to believe me. I want you to have a reason why we're doing stuff. Okay? So, another way that I've seen it taught is this. If it's x minus 4, what's the original formula? X minus h. And if h is the amount that we move horizontally, would that make sense? The h is the amount of that we move horizontally. How are we moving horizontally? How many? 4. Because the negative is part of the formula. Yes? So would it make sense if I would move right 4 since h is 4? Yeah. Okay? And the last way, well, another way I've seen it taught is if we take what's inside of this function, in this case x minus 4, and we set it equal to 0 to see how far we move to the right or left, wouldn't I add 4 to solve for x? And x is 4. Does that make sense? Okay? Whichever way works best for you, use it. They're all true. If you want to just believe me, okay. Right? I'd rather you have a reason so you can get back to it if you forget exactly what to do. Okay? So can somebody make me a conjecture of how m of x is going to change compared to its parent? Horizontal shift. Horizontal shift. Remembering your f's, please, all the way through. And you think it's going to move left 5? Does anyone agree with him? 4 people? Excellent. You guys are all right. First of all, because you can just believe me that it does. Or we could set this equal to 0 and solve for x, which we would get -5, which would mean we'd move to the left 5. Or if it's x minus h, wouldn't that have to look like x minus a -5 to be right with the formula x minus, which means that number would have to be -5. Left 5. Questions? Okay. The next two types of transformations. Let's do 2 times the absolute value of x, and let's do 1/3 times the absolute value of x. Any guesses, first of all? Maybe you don't know all of it, but maybe you have enough to make an initial directional guess. Where is the 2 in relation to the original parent function? It's outside, isn't it? What did we say a minute ago is true about if it's outside? It's some sort of vertical change, right? So that is true. It is a vertical change. This one, let me grab another piece of paper real quick. If I took absolute, let's get it right like that. Okay, if I took an absolute value, let's make this, let's make that the parent. I know you can't see it very well, I don't want you to. Okay, but if I went over 1 and up 1, what's this 2 telling me to do? What's the 2 doing to the absolute value? It's multiplying, isn't it? It's doubling it. So instead of going over 1 and up 2, I'm going to go over 1 and up twice that far. Instead of going over 2 and up 2, I'm going to go over 2 and up twice that far, to 4. Instead of going over 3 and up 3, I'm going to go over 3 and up twice that far, to 6, right? So instead of being like this, it's going to be like this. What do you think that's called? It was here, now it is. What kind of words would you use to describe that? Oops. Can you make your guesses out loud? Okay, think about it this way. The pencil function, what if I held on to it right here and grabbed the top of it right here and went like that? Would it change the shape to that? Would that make sense? What did I just do? If I held on to this and what did I do to it? Stretched. I stretched it, didn't I? Okay, so guess what this is called? A vertical stretch. This is a vertical stretch by a factor of 2. Because that's what the number is that I'm multiplying. It's a vertical stretch by a factor of 2. Okay? What I need you guys to know is when I'm in the back of the room like this and the air comes on, I can't hear you very well. So if you guys are sitting there going, stretch, I think it's stretch, I can't hear you. And I don't have any way to know that you're such a genius as you are. So just say it a little louder. Deal? Thank you. So what do you think is going to happen on P of X? Oh, okay. Let me show you something real fast. F, G, H, J, K, M, N, P. Earlier class today was concerned that I didn't know my letters. Okay? Why didn't I use I or L? Because it looks like a 1. That's why I don't use I or L. Are you okay that are you confident that I know my letters? Okay, just checking. How do you think P changes from F? Where's the multiplier? On the outside, so how can I start this? Vertical. It's going to go what? You're showing me with your hands. Yes, that's absolutely right. What did you say? What words did you choose? It's going to go further flat, right? So it's if I held on to the bottom of this and I went, you can make the sounds if you want. I mean, that's up to you. But what did I do to that absolute value function this time? What? I squeezed it? I smashed it? So both of those words are absolutely fine, and if you put them on a test, that would be great. They're not the words that might show up on a standardized test. Okay? That word would be a compression. Okay? Vertical compression. By a factor of what? 1/3. So how in the world do you tell the difference if it's a stretch or a compression? Hopefully you've already told, and I've heard a little bit of discussion. You knew it was going to be vertical because the number was on the outside. And what is that number doing to the absolute value, to the original function? It's multiplying. So it's going to be a vertical either stretch or compression, but how do you tell the difference? You just guess? Hope for the best? That'll work probably about 50% of the time, right? You want a 50 on your test? No. So let's figure out a way. For the record, there is a way to know. Okay? There is a way to know. So how are we going to know? This is a 2, and it's a stretch. It could be a 5. It could be 3.6. It could be 9/4. What's true about all those numbers? Could be 723. Absolutely right, Mary. Absolutely right. We're going to call that number A because that's what we called it up here, the main multiplier in the front. A has to be greater than 1. A has to be greater than 1. So using your logic, I'm going to try to trick you. I'm telling you up front. I'm not just trying to, do it sneaky and stuff. I'm telling you I'm trying to trick you. Using your logic, what would make it a compression then? If it's less than 1, that's logic, right? But that's not all the way right. Okay? A is less than 1. That's part of it. But think about this. -3 is less than 1, isn't it? But -3 would cause a stretch. Because if we have -3, what's the negative going to do? It's going to reflect it. Once we reflect it, the negative is like taken out of the mix. And what's left there? A 3. That's a stretch because it's greater than 1. So not only does it have to be less than 1, but it also has to be, say it out loud, greater than 0, right? Greater than 0. Now somebody earlier said, oh, so it's a fraction. Isn't that a fraction? Yes, but it's greater than 1, right? So just be careful with your vocabulary there. Be careful with your word choice, okay? You could say it's a fraction between 0 and 1. I'd be okay with that. Or you could just say it has to be between 0 and 1. Any questions? All right, so here's what I would like to do. I would like to show you the hardest problem that you will have on your homework today and see if you can do it. For the record, that's not how I normally do it. We usually try to take little baby steps and teach you a little baby part and then make it a little bit harder, so like a toddler problem. No. Today we're just going to tear the Band-Aid off, right? Okay? F of x is the... Ooh, I'm even going to trick you even more. You ready? I'm going to try to trick you even more. F of x is going to be x squared. Have we talked about x squared at all today? Do you remember what we said last time we met together? If you know it for one family of functions, then what? You know it for all. You remember us talking about that? Okay, but I'm trying to trick you, remember? So we're going to talk about x squared. I want you to tell me how g of x is different from its parent. I don't want you to have a sissy-pansy problem. I'm even going to make it harder. There. You ready? Does it matter what order we write down the transformations in? For the record, it does. Okay? But it's really easy to know which order it goes in because you just have to read the problem. If we read the problem from left to right like we read, we'll get it all in the right order. Reflections have to come first if they're there. Okay? So, does this problem have a reflection? Where does it reflect? Reflects over x-axis. What's next? Oh, hold on. I have to fix something. Fix it. Before we go on, fix it. I forgot to put the squared there. You'll be fine. You'll be fine. Rude. Big fat babies. So, first things first, we got to the negative sign, and we knew that reflected over the x-axis. What do we get to next? The 1/3. What does that cause? Vertical compression by a factor of 1/3. That's a 3. It's hard to write with Sharpies. So we took care of the negative, that was a reflection. Took care of the 1/3, that was a vertical compression. What comes next? 41. What happens with the 41? It's inside, so it is horizontal shift. Which direction? Left 41. For the record, did I really make it harder by adding bigger numbers? No, not at all. I made it harder to graph, but we don't care about that right now, do we? Okay, so I took care of the negative, that was the reflection. I took care of the 1/3 because that's the vertical compression. Then what's the 41? What does that do? What's the squared do? Does it do anything? It only does one thing. It gives it its shape. That's what the parent function was, right? Does it change anything when we're talking about g of x? No, it's telling you it's keeping the same shape. It's keeping a parabola shape. It's not going to absolute value all of a sudden or something like that. Okay? Once we start with the quadratic, we want to keep a quadratic. So that's what the square does. So what's left? Good. Vertical shift down 62. So here's the, wait, was that hard? No. So here's the hard part, quote unquote. If I start here with my parabola, I reflected it, so I got here, right? And then I compressed it by 1/3, so I got here, it's flatter, right? Then I have to move it left 41 and down 62. I'm going to finish this video, so if you want to go watch the rest of it tonight, you can. Otherwise, do your homework. 39 through 44, the directions in the book are a little different. This is what I want for 39 through 44. Tell me this and the domain and range. Okay? So if I moved it left 41 and down 62, that would put me a parabola that goes like this, right here. with the vertex being left 41 and down 62. Okay? So when I'm talking about my domain, I'm saying how far left and how far right does it go? Well, it's a functional parabola, so my domain is going to be negative infinity to positive infinity. My range, however, if I'm saying how far down and how far up does it go, because it's reflected, it goes all the way down. So from negative infinity, and how far up does it come? What y value does it come up to? It comes up to 62. That is my, it gets to 62. So that's a bracket right there, and that's my range. So that's the kind of stuff you have to do on the last part of the assignment. I hope you have a great day. Peace.